When is failure theory applied in machine design? Have you ever wondered when engineers turn to failure theory in machine design? This is a key question that impacts the safety and efficiency of countless machines we relying on every day. Failure theory is crucial when engineers need to predict if a part will fail under specific loads. It is especially important during the design phase to ensure that components can handle the stresses they will face. Engineers apply failure theory to determine how much load a component can withstand without breaking. This includes parts that experience axial forces, bending moments, torsion, or even complex stress combinations. By understanding these factors, designers can keep operational stresses below critical limits, which helps prevent failures. When designing components like shafts, pressure vessels, gears, or engine parts, engineers must consider the types of stresses acting on each part. They look at normal stress, shear stress, and principal stresses to assess how the material will behave under load. Choosing the right failure theory is essential and depends on whether the material is ductile or brittle and the specific loading conditions. Once the appropriate theory is selected, engineers calculate the allowable stresses or load limits for the design. They often use computational tools like finite element analysis to simulate real-world conditions. This helps identify potential failure points before the component is even built. Common failure theories include the maximum normal stress theory, which states that failure occurs if the maximum tensile or compressive stress exceeds the material's ultimate strength. The maximum shear stress theory, also known as Tresca, indicates failure when the maximum shear stress surpasses the shear yield strength. The distortion energy theory, or von Mises, is often used for ductile materials under complex loading conditions. For components that face cyclic loading, fatigue failure theories come into play. These theories help predict how long a part will last before fatigue failure occurs, which is vital for safety and reliability. Applying failure theory is not just about avoiding catastrophic failures. It also helps prevent overdesign, which can lead to unnecessary material use and increased costs. By accurately predicting failure, engineers can optimize designs for safety, durability, and efficiency. In machine design, failure theory is applied whenever there is a need to understand and prevent material or structural failure under expected service loads. This ensures that the components perform reliably throughout their intended life, making it a fundamental aspect of engineering design.